So let's continue with coding the machine. Now we're going to start off again by generating a new file. So we can get into our ASM, we will right click, new file, and all of the files I've decided to start them off with the values CTM. Okay, so CTM stands for code the machine. I've just done that so that we can keep all of the files together and it's easy for us to find them. Okay, so we'll go CTM and we're going to continue our route. From the last video we did addition, we will work through addition, subtraction, multiplication and division. So we can call this basic arithmetic, and remember to give it the extension .asm, which stands for assembly. So that's us got our file. We know we can't do anything until we tell the assembler whereabouts the code is actually in memory, and we're going to have it at origin 0x8000. Now if we want to, we can put the numbers into the register, so data, and you already know how to do this, so you can go ahead and choose your numbers, #2, R0, and data #3, R1. Now we seen in the last video we could do add R0, R1, and this would give us the value of R1 is equal to the 2 plus 3 is equal to the value of 5. Now we can also do the subtraction, so we could put in sub, and we're going to deal with only positive numbers for the moment. The machine does deal with negative numbers, but we'll leave that to a different video. So we're going to do, say, 5 minus the value of 2. So we're going to have R1, R0. Now the way to read this again is that we have the command, then we have the source, then the destination. Okay, so the final destination is going to be register R0. So we can read this from left to right as R1 minus R0 is equal to the value of R0. So this then should say we take the value R1, which is 5, we take away the value of R0, which is still 2, and it means that in R0 we should get the value of 3. Okay, so that's how we do the subtraction. Now let's say we wanted to do a multiplication. So we can do MULT, multiply, and let's say we're going to multiply together. Well, register R0's got the value of 3. So let's say we multiply R0 with R0. So we're just multiplying the 3 by the value 3. Okay, so it means that R0 will then equal 3 times 3, which will equal a value of 9. Okay, quite straightforward. Now we also want to be able to do division, so we can say div now, and then we can divide the two of the values out. So let's have a look and see. We're going to have the value of 9 in the register R0, and we're going to have the value of 5 in register R1. Okay, so the way that we do this, if we wanted to say, for example, 9 divided by 5, then we're going to put the 9 first. So 9's in register R0, so it would be R0, comma, and the other one we're going to do is 5, which is in register R1. Okay, so that means that what this tells us is we're going to do 9 divided by 5. Okay, now the thing about the division is that we know that when we do 9 divided by 5, we should get a value of the 1. So the quotient, I'll just put in Q equals 1. Okay, so 5 goes into 9 1 times, and the remainder here is going to be the value of 4. And the way that this works is it will put the value of the quotient into register R0. Okay, so we should have R0 is equal to the value of 1, and then the remainder will be in the register R1. So R1 will be the value of 4. Okay, so I'll put R1 will equal 4. Okay, so that's the way that the division works. The division will give us the quotient and the remainder. Of course, it does overwrite the original values, so if you want to keep the original values, you would have to make sure you take them and place them somewhere else or make a copy of them. But there's easy ways to do that using the stack, which I will show you later in a different video. So that's add, subtract, multiply and divide. So we'll put in the end command, and that should be us finished. So when we're finished, we should see that register R0 has got the value of 1 and register R1 has got the value of 4, if it all works out. So let's actually run this up and we'll see it working. Okay, so I first of all will have to say terminal and run task. Okay, assemble file, and it says assembly successful. I'll let you see that. So you see assembly successful, which is always good. Now let's actually run up the Logisim now. Pop on this, I'll pop this one off, and we should get Logisim. So we'll go simulate, and I can reset it. I'll reset it here. I can drop down in, edit, open. Now my files are in the directory Python, and design a CPU 3, uassembler, machine code, and I called this basic arithmetic. Okay, close window, design, user panel, and then we can simulate it. So I can say simulate, tick enabled. So just as a reminder, we said that we're going to have the value of 1 in register R0 and 4 in register R1. Okay, so 1 and 4. So simulate and tick enabled. So it should run through it quite quickly, and there you see it has actually done what we said it would do. We've got a 1 in register R1 and a 4 in a 1 in register R0 and a 4 in register R1. So that's just some basic arithmetic, nice and easy. What you can do is you can take the commands that you've learned so far. So we've got our add, subtract, multiply and divide, and we've got our data commands, and you can load up the machine and just mess about with it, generate a simple arithmetic, and see that you get the answers that you expect to get whenever you run the code. So that's all for this video. We'll continue on the next video, and as we work our way through, things will get a lot more exciting and interesting as we get into some more nitty gritty, more details and more of our commands.